So the induction motor will convert the electrical energy into what? Mechanical energy. So it is a motor. If there is a mechanical energy converted to electrical energy, it is generator. So this electrical energy which is converted into mechanical energy, here motor can be used in different applications.
Used to drive pumps, fans.
So these are the applications where we use motors. Even it is a single phase motor or three phase motor, these are the applications to drive pump, fan, compressor, gearbox, pulley, etc. We use three phase motors or single phase motors.
Presses, gears, pulleys, etc. Almost all the parts are held inside the main housing. At the front,
So the housing is a cover of a motor. So on the housing we have a fins of aluminium fins which will be used for cooling the motor rapidly. Cooling the motor rapidly.
we find the shaft. This is the part that rotates.
So this is a shaft where you get mechanical energy. So when the motor rotor is driving, the rotor is connected with the shaft, and this shaft will be giving you the mechanical energy.
But we can connect things like pumps, gears and pulleys to this to do work for us. At the back, we find the fan and a protective cover.
So this fan is connected on the opposite side of the shaft. Okay, on the opposite side means back side of the shaft. The fan is particularly used for purpose of cooling the motor. Okay, so with the motor when it is driven or when it is used for long period of time continuously in the industrial purpose or industrial application, the motor tends to get very heated. So the winding of the motor gets maximum temperature when it is used continuously. So to avoid that, to overcome that heating, we use this fan to rotate for making of purpose of cooling. Okay, they will ask you question, what is the purpose of cooling fan? For making the motor cool. Understand, sir?
Yes. But the fan is connected to the shaft, and so it rotates whenever the motor operates. That's because the induction motor.
So as I told you, when the induction motor is continuously driven in the industry for continuous period of time for 24 hours per 7, the motor gets maximum temperature, it gets very hot. Okay, so to avoid that we use cooling fan. Okay, and even the second reason for the motor to get very hot is starting current. Okay, whenever the motor is starting, the current will be very maximum. Sometimes 6 to 7 times of the rated current. Rated current may be 10 ampere, but when the starting current it goes till 50 ampere, 60 ampere. This 50-60 ampere tends to damage the winding of the motor. So that is the reason why we connect the motor in star delta. Okay, I will teach you that in future. So please see.
Can produce a lot of heat when in operation, so the fan blows ambient air over the casing to cool it down. If the induction motor became too hot, the insulation of the internal electrical core.
So this is the output. If the induction motor becomes over hot, when the winding gets burned, the winding when it is burned, it will look like this. So the motor gets damaged and it is not suitable for working condition. Okay.
Oils will melt. This will cause a short circuit and the motor will destroy itself. The fins on the side of the enclosure help to increase the surface area, and that lets us remove more unwanted heat. The shaft is supported by some bearings, which sit inside the front as well as the rear shields. The bearings help the shaft rotate smoothly.
So another part, what is very important is bearing. So what is the use of bearing? This bearing will avoid the friction between the shaft and the motor casing. Motor casing is rotor and other parts. So this bearing will act or will make the shaft to rotate smoothly. For example, when you test the motor, when you rotate the shaft, when you are testing the motor, if the shaft rotates smoothly, then both bearing is good. If the shaft is not rotating, within one turn it stops, or it is very tight, then means bearing mushkila, bearing problem. Bearing problem, if you change the bearing, the motor will become normal. So what is the purpose of this bearing? Bearing will make the shaft to rotate smoothly. Okay, so this will give you the maximum efficiency of the motor to give you the mechanical power. If the bearing khalas, carbon, it will not give you maximum efficiency. Even the motor rotor is driving very hard, but the shaft will not give you output You understand, sir?
and also hold it in position.
See, each part they will ask you
Inside the
question.
housing, we find the stator. The stator is stationary.
So now very important part in the motor is rotor and stator. They will ask you question, what are the important parts of the motor? Rotor and stator. So stator is a fixed part. We call this in English static part or stationary part. Static part, stationary part, fixed part, non-moving part. Everything is the name given to stator. That means it is just standing, it will not move. Whereas rotor is the active part, rotating part, or we call this as moving part. It is rotor. It is rotor. So come on, this stator in three-phase motor, we have three windings. We have what, my dear? Three windings where we supply the three-phase power supply. Okay, you can just see here R, Y and B. R, Y and B. So these are the three different phases where we initially give the power supply to make the stator coil magnetic field, to make inducing the magnetic field to the rotor. You understand, sir? Please listen carefully. Now you have to listen very important. They will ask you more questions after this.
And does not rotate. This consists of a number of copper wires which are wrapped into coils between the slots positioned around the inner perimeter. The copper wires are coated with a
So you can see, you see before before this slide, there was a copper wire winded. You may have doubt. The copper wire is fully winded. They may be contacting a short circuit. What they use here, they use enameled copper wire. Enameled copper wire means they will not get contact. There is a coating in the wire. So even it touches in the part, it will not get contact, so that the magnetic flux will be 100%. Whereas if it is not enameled standard wire, the short circuit will be here happen, and there will not be 100% magnetic field. You understand, sir?
a special enamel, which electrically insulates the wires from each other. This means electricity has to flow through the entire coil. Otherwise, it would take the shortest path possible, and we'll see why that's important a little later in this video. Now, this is a three-phase induction motor. So, we have three separated sets of coils.
So you can see here three-phase induction motor. The stator coils are three different separate colors. You can see red color R phase 1 and red color phase 1 and yellow color phase 2 and blue color. We call this RYB. Okay. So this red color you will give here one. The wire will be connected to the terminal box, and here will be connected to the terminal box. So we have primary wire and secondary wire. Primary wire will be denoted as U1, V1, W1. Secondary wire will be denoted as U2, V2, W2. Okay. How many have experience here in motor? Sir, what are you, sir, sleeping? Early morning without breakfast, I am shouting like this, you are sleeping. Oh my God.
Coils in the stator. The ends of each set will connect with the terminals within the electrical terminal box. We will also see how these are connected a little later in this video. When connected to the electrical supply, the stator generates a rotating electromagnetic field. Connected to the shaft is the rotor. In this case, it's a squirrel cage type rotor. It's called a squirrel cage because it has two end rings which are connected by some bars, and these will all rotate together. This design is similar to a small cage or an exercise wheel used by a pet hamster or a woolly squirrel. The squirrel cage is fitted with a number of laminated steel sheets. These sheets will help concentrate the magnetic field into the bars. Sheets are used instead of a solid piece of metal, as this improves the efficiency by reducing the size of the eddy currents in the rotor. When the rotor is placed inside the stator, and the stator is connected to an electrical power supply, the rotor will begin to rotate. So, how does this work? When electricity passes through a wire, an electromagnetic field is generated around the wire.
So this is the principle, basic principle. What is the principle? When you have a coil, And when you give the electrical current to the coil become magnet. The coil become magnet. It will have a magnetic nature. So it will generate electromagnetic field. So this is the basic principle which is acting in the motor. So in the motor you have a coil called stator coil. In the stator coil you will give the power supply. When you give the power supply AC current, the coil will become magnet. Because of the magnetic field in the stator, the magnetic field will be induced in the rotor also. Okay, we will see.
Now, we can see this by placing some compasses around the wire. Will rotate to align with this magnetic field. If the direction of current is reversed, the magnetic field also reverses, and so the compasses will change direction. The magnetic field of the wire is pulling and pushing the compass diodes, just like if we slide two bar magnets towards each other.
So this is the principle of a magnet. When you have two different poles, it will attract. When you have two same poles, it will repel. Okay? Because of this attraction and repulsion force,
And even use one magnet to rotate another. Or we can also rotate the magnet by changing the intensity of the magnetic field around it. If we place a wire in a magnetic field and pass a current through it, the magnetic field of the wire will interact with the permanent magnet's magnetic field, and the wire will therefore experience a force. This force will move the wire either upwards or downwards, depending on the direction of current and the polarity of the magnetic fields. If we wrap the wire into a coil, the electromagnetic field becomes stronger. The coil will produce a noise.
so what will be in the form of coils, circulating coils. The electromagnetic field will be zyada. Zyada means more efficient, rather than a straight wire. So that is the reason why you can see the stator, it is in the form of coils. It is in the form of coils. You understand, sir? So they will ask you in interview. They will not ask you in this Aramco exam. Why the stator coil is stator coil is in the form of circular coils? Because if it is straight, sir, it will not produce maximum magnetic field. When it is in the form of coil, it can produce more magnetic field and make the efficiency of the motor higher. You understand, sir? These are the interview questions. Don't miss it. Okay, while I am teaching, I will give you some tips also. So please note it down all this. So when you give the electrical power supply, the coil becomes as a magnet and it has a basic nature of south pole and north pole. Okay, fine.
It's like a permanent magnet. We call these coils of wire an inductor. When we pass an alternating current,
You see here, when you give the coil DC power supply, the south pole and the north pole will remain same. Why? Because DC power supply, the polarity will not change. Whereas in AC power supply, the north pole and south pole will change in respect to each cycle. Which change with respect to each cycle because the polarity changes. Understand, sir?
backwards. So the magnetic field will also expand and collapse, and the polarity reverses each time. When we place another separated coil in close proximity and complete the circuit,
So see here, assume this is a stator coil and this is a rotor coil. When you give the current to this stator coil, it happens a magnetic field. When you bring this rotor coil near to this, what happens? The same magnetic field will be induced here. Induced means, what do you mean by induction? Induction means it will exhibit the same nature. For example, I am a bad guy. If my friend, he comes with me, he will also experience all my bad practice. That is called as induction. He will induce my bad habits. You know, similarly, this electromagnetic field in this coil, in the stator, will be induced in the rotor coil.
the electromagnetic field will induce a current in the second coil. We can connect two coils together and place them opposite each other to
See,
create.
this is a single phase explanation. Please underline, please listen carefully how the single phase is not moving. Please listen carefully.
A larger magnetic field. If we place a closed loop of wire inside this large magnetic field, we will induce a current in the loop. As we know, when we pass a current through a wire, it generates a magnetic field. And we also know the magnetic fields will push or pull each other when they interact. So, this loop of wire will also generate a magnetic field, and this will interact with a larger magnetic field. Each side of the coil will experience opposing forces, which causes it to rotate. This loop is therefore our rotor, and the coils are therefore our stator. The rotor will only rotate until it aligns with the stator coils. At this point, it will likely get stuck, as the induced current reverses with the coil. To overcome this, we need to introduce another set of coils in the stator. We must connect these to another phase. The electrons flow in this phase at a slightly different time. So, the electromagnetic field will also therefore change in strength as well as polarity at a slightly different time. This will force the rotor to rotate. Inside the induction motor, we have three separated coils which are used to produce a rotational electromagnetic field. When we pass an alternating current through each coil, the coils will produce an electromagnetic field which changes in intensity as well as polarity as the electrons change direction. But if we were to connect each coil to a different phase, then the electrons in each coil will change direction at a different time.
So when you have the same three coils in same phase angle, you will not have much efficiency in the motor because it is giving you same magnetic field. But when you change each phase in different phase angle, about 120-degree difference of each angle, what happens when it leave one phase, when it leave another phase, it will get catch, and then another phase. So they will ask you what is the phase angle between each phase. It is 120 degree. It is 120 degree in three phase.
This means the polarity and intensity of the magnetic field will also occur at a different time. To distribute this magnetic field, we need to rotate the coil sets 120 degrees from the previous phase. We then combine these into the stator. The magnetic field varies in strength and polarity between the coils, which combine to produce the effect of a rotating magnetic field. We saw earlier in this video that current can be induced into a second coil when in close proximity. The bars of the squirrel cage are shorted at each end, which therefore creates multiple loops or coils. Each bar therefore induces a current and creates a magnetic field. The magnetic field of the rotor bars interacts with the magnetic field of the stator. The rotor bar's magnetic field is attracted to the magnetic field of the stator. As the magnetic field is rotating, the rotor will therefore also rotate in the same direction as the magnetic field to try and align with it, but it will never be able to fully catch up. The bars of the rotor are often skewed. This helps distribute the magnetic field across multiple bars and stops the motor being able to align and jam. The stator contains all of the coils or windings used to create the rotating electromagnetic field when electricity is passed through the wires. To power the coils, we find an electrical terminal box on the top, or sometimes on the side. Inside this box, we have 6 electrical terminals. Each terminal has a corresponding letter and number. We have U1, D1, and W1, then W2, U2, and B2.
Primary, secondary.
We have our phase 1 coil connected to the 2 U terminals, then the phase 2 coils which are connected to the 2 V terminals, and lastly the phase 3 coil which is connected to the 2 W terminals. Notice that the electrical terminals are arranged in a different configuration from one side to the other. We will see why that is in just a moment. We now bring in our 3-phase power supply and connect these to their respective terminals. For the motor to run, we need to complete the circuit, and there are 2 ways to do this. The first way is the delta configuration. For this, we connect across the terminals U1 to W2.
So when you connect, I told you, when you connect the direct online starter, when you connect CETA, 3-phase power supply, which are this one, what happened? The motor starting current will be very high. So to avoid the direct online starter for the big motors, we connect the motors in star and delta connection. In star and delta connection. So this is the delta connection fashion. The primary and secondary will be short circuited, so it will be arranged like this. Understand, sir? So if you want, you can take picture of this so that you will get a reference whenever you want to see. Okay?
V1 to U2 and W1 to V2. This will give us our delta configuration. Now, when we provide AC current through the phases, we see that electricity flows from one phase to another as the direction of AC power reverses in each phase at a different time. That is why we have the terminals in different arrangements in the terminal box. Because we can easily connect across and allow electricity to flow between the phases as the electrons reverse at different times. The other way we can connect the terminals is to use the star or Y configuration. In this method,
So in star configuration, the secondary coil will be short circuited. So this will form like this. Okay? So now we will see which one is better, delta or star. See, in starting current is Zyada for big motor, we choose delta and star connection. Among these two, which one is better? Star is better or delta is better? Which one is having less starting current? We will see.
we connect between W2, U2, and V2 on only one side. This will give us our star or Y equivalent connection. Now, when we pass electricity through the phases, we see the electrons are shared between the terminals of the phases. Due to their design differences, the amount of current flowing in the star and delta configuration
We'll
is
see
very
now.
different. But we're going to see some calculations for these towards the end of this video. But first, I want to tell you about the great setting, change number 2. Can you take the link? Let's have a look at the difference between the star and delta configurations. Let's say we have the motor connected in delta with a supply voltage of 400 volts. That means when we use a multimeter to measure the voltage,
So now, please listen here, my friend. They will ask you a question. In three-phase motor connection or in three-phase power supply, each phase is 230, 230, 230. Line to neutral is 230. Line to neutral is what? 230. What will be the line to line? It is 400. How? Square root of 3. 230 into square root of 3. So this will give you 400. So square root of 3 is 1.732. 1.732. So 1.732 into 230, it will give you 399.98 something. So it is 400. You understand? Sure question they will ask you. Understand, sir? Yeah.
Yes, sir.
between any two phases, we will get a reading of 400 volts. We call this our line-to-line voltage. Now, if we measure across the two ends of a coil, we again see the line-to-line voltage of 400 volts. Let's say each coil has a resistance or impedance, as this is alternating current, of 20 ohms. That means we will get a current reading on the coil of 20 amps. We can calculate that from 400 volts divided by 20 ohms, which is 20 amps. But the current in the line will be different. It will be 34.6 amps. We get that from 20 amps multiplied by the square root of 3, which is 34.6 amps.
So you see here, so the starting current will be around 34.6 amps. 34.6 amps in delta connection. In what? Delta connection. So we'll see what is the starting current in star.
That's because each phase is connected to two coils. Now, if we look at the star or Y configuration, we again have a line-to-line voltage of 400 volts. We see that if we measure between any two phases, but with the star configuration, the star point, or neutral point. It's from this point that we can run a neutral wire if needed. So this time, when we measure the voltage across the ends of any coil, we get a lower voltage of 230 volts. That's because the phase isn't directly connected to two coils, like in a delta configuration. One end of the coil is connected to a phase, but the other is connected to a shared point. So the voltage is therefore shared. The voltage is less, as one phase is always in reverse. We can calculate this by 400 volts divided by the square root of 3, which is 230 volts. As the voltage is less, the current will be 2. If this coil also has the impedance of 20 ohms, then 230 volts divided by 20 amp.
So here when compared to delta, the star is having only 11.5. So they will ask you in interview which one is better, delta or star. So you have to say it is a star is less when compared to delta. So that is the reason why very big motors, more than 50 HP motors and all, they will connect in the star connectivity.
Equals 11.5 amps. The line current will also therefore be the same at 11.5 amps. So we can see from the delta configuration, the coil is exposed to the full 400 volts between two phases, but the star configuration is only exposed to 230 volts between the phase and the neutral point. So the star uses less voltage and less current compared to the delta version. Okay,